As we know, mathematics is an area of knowledge that includes the topics of numbers, formulas, and related structures, shapes, and the spaces in which they are contained, and quantities and their changes. These topics are represented in modern mathematics with the major subdisciplines of number theory, algebra. Most mathematical activity involves the discovery of properties of abstract objects and the use of pure reason to prove them. Let's understand this by an example. Fermat's last theorem. This conjecture was stated in 1637 by Pierre de Fermat, but it was proved only in 1994 by Andrew Wiles, who used tools including scheme theory from algebraic geometry, category theory, and homological geometry is one of the oldest branches of mathematics. It started with empirical recipes concerning shapes such as lines, angles, and circles, which were developed mainly for the needs of surveying and architecture, but has since blossomed out into many other subfields. A fundamental innovation of Greeks was the concept of proofs. It is not sufficient to verify by measurement that say two lengths are equal. Their equality must be proven via reasoning from previously accepted results slash theorems and a few basic statements. The resulting Euclidean geometry is the study of shapes and their arrangements constructed from lines, planes, and circles in the Euclidean plane and the three-dimensional Euclidean space. It developed without change of methods or scope until the 17th century, until René Descartes introduced what is now called Cartesian coordinates. This constituted a major change of paradigm. Instead of real numbers at lengths of line segments, it allowed the representation of points using their coordinates, which are numbers. Algebra can thus be used to solve geometrical problems. Algebra is the art of manipulating equations and formulas. Diophantus and Al-Khwarizmi were the two main precursors of algebra. Diophantus solved some equations involving unknown natural numbers by deducing new relations until he obtained the solutions. Al-Khwarizmi introduced systematic methods for transforming equations, such as moving a term from one side of an equation into the other side. Algebra became an area in its own right only with Francois Viete, who introduced the use of variables for representing unknown or unspecified numbers. During the 19th century, the concept of algebraic structures consisting of a set whose elements are unspecified of operations acting on the elements of the set and rules that these operations must follow. The scope of algebra thus grew to include the study of algebraic structures, was called modern algebra. Some algebraic structures have useful and often fundamental properties. Their study became autonomous part of algebra and include group theory, field theory, vector spaces, ring theory, commutative algebra, homological algebra, Lie algebra, Lie group theory, Boolean algebra.